Picking it up where we left off, here's part B. Let's take a look at the integral of the natural log of x divided by x squared dx. And you see I'm covering something up here. Okay, so you think for a second, okay, natural log of x divided by x squared. How should we choose the u and the dv? You're like, wait a second, we're dividing, and the formula is multiply. So how's this even going to work? Okay, we're going to have to think of this as a product. It has to be u times dv. We can't work with it with division. So here's what we're going to do, and here's the first way, what I'm going to reveal here. We need to think of x squared in the denominator as x to the negative 2. And then it's a multiply. And you even see the choice for u and dv there. We're going to take u to be natural log x, and we're going to take dv as x to the negative 2 dx. Again, how would I know to pick it that way? There's some trial and error with these. When you're starting this, you don't know how to pick it, but you try something and you see if it works and if you make progress, and if your new integral here, the v du, is that simpler than the original, right? Are you making progress? Also, for this one, I don't think I put on my page, but we can do it the other way around, and it won't take long to realize you could not reverse these. But let's do that at the end. Okay, here we go. Taking u as natural log x and dv as x to the negative 2 dx, I've got it all laid out here for us. So u equals natural log x, dv equals x to the negative 2 dx. All right, then what is du? Well, take a derivative, and hopefully you remember the derivative of natural log x is 1 over x dx. For the dv, we need an antiderivative. X to the negative 2. Okay, so the exponent would have come from negative 1, which means there's a negative here because the negative 1 multiplying down, and okay. So there's your antiderivative of x to the negative 2. Now, for our purposes, I prefer to think of this as negative 1 over x. I find the problem unfolds a little bit easier thinking of it that way, just the way this is going to go. Also, because du we're thinking of as a fraction, let's think of that as a fraction as well. Okay. So using this as a guide, we're going to write what we see on the right side there, uv minus integral v du. And I'm going to have these equal signs, which some reason I don't want to use those right now. Okay, so this becomes this, becomes this. All right. U v minus v du. Okay. So this first part, there's never going to be really much to do with this except simplify it, if you can. It's all about that new integral, and can we perform that new integral? Okay, let's simplify before we do anything else. Well, this, typically we'd put the negative 1 over x first, or maybe you could write negative natural log x over x. That's all up to you. What happens here? Well, negatives cancel, right? Plus. And now I'm going to think of these as an x to the negative 2, right? 1 over x squared. Now the question becomes, is this simpler than the original? And we're kind of thinking of the original back here. Oh, yeah, definitely. I mean, we still have x to the negative 2, but now the natural log is gone. This is great. We're doing it right. Perfect. Let's finish it off. That antiderivative, hey, we just did that same thing a moment ago. Negative x to the negative 1 plus c, and we could circle that answer. I went ahead and wrote it. Either of these are fine. That's fine. Or this, write it as a fraction. This is a fraction, so it's kind of nice to have consistency, but You know, that's being pretty picky. That's my own personal preference to some degree. Both those completely correct. Okay. Let's see what would happen if we tried this one the other way around. Maybe I'll just put that out over here. Okay, so if we thought of it as integral x to the negative 2 natural log x dx, and this was u, and this was dv. Why would that not be a good idea? We'd be able, you might not see it at first, but it would be pretty clear really quick. So if we wrote this out, right, u equals x to the negative 2, dv equals natural log x dx. So then du, well, now that's a derivative happening, right? Negative 2x to the negative 3. And we need to put the dx on there. A lot of people don't write the dx. And that's kind of the nuance of it's actually not a derivative, it's a differential. So we need that dx on the end. Because we need the dx at the end of the integral, people. Come on. Okay, so far so good, no problem. Now dv. So what does v equal? If dv equals the natural log of x dx, then what's that antiderivative? Yeah, we never learned that. We know the derivative of natural log x, but we don't know the antiderivative. I don't know. Well, if you don't know, then I guess this wasn't the way to do it. So yeah, we're not going to approach it this way. Okay, moving on. That's a good sign. Right? If you don't know what you never learned the derivative. Oh, I'm revealing too much. On example C, my mistake. Okay. Now let's mix things up a little bit. We still are going to begin with a fraction, but now we involve e to the x, and we're going to put the e to the x in the denominator. So check it out, part C. Integral x to the third divided by e to the x dx. Well, we see that fraction, right? We can't work with a fraction. The formula is based on multiplication. So here's what we'll do. We'll think of it as e to the x becomes e to the negative x. And this time, this would be a lot nicer. This would be a lot more interesting if we were in the classroom together and I could say, which should we pick for u? Which should we pick for dv? You know, should we switch them and think of this as u, you know, or is this u and this is dv? But since you can't interact with me here, I'm just going to tell you. We should pick x to the third as u and e to the negative x dx as dv. Now that might come as a surprise because that previous question, right, with the natural log we picked as u, and the x to the power was the dv. But here, it's the reverse. And again, there's trial and error there. If you were to pick it the other way around, then the new integral would be more difficult. So we don't need to walk through that. I think we pointed to that already. If you were to switch these, then when you get that new integral, it's going to get more complicated. So I'll just tell you here, u is x to the third, e to the negative x dx is dv. Okay, so let's see it. Let's see all the parts together. So u equals x to the third. So that means du, taking a derivative, 3x squared dx. Okay. dv, e to the negative x dx. So antiderivative, negative e to the negative x, reversing that chain rule. Technically, you could think of this as a u sub with u equaling negative x, but it's a rather simple one. hopefully we can get our head wrapped around, yeah, just that negative would multiply down, and we can see that. Okay. So let's write out the right-hand side. So we've got u v minus integral v du, all right there. E to the third, excuse me, x to the third times negative e to the negative x minus integral negative e to the negative x again times 3x squared dx. Okay, let's simplify this before we do anything else. All right, so here, well, just move that negative sign out front. There's never going to be much to do with this first part. Negative x to the third e to the negative x looks a little bit better. Here, negatives combine, right? Let's move that constant 3 in the front of the integral. X squared e to the negative x dx. Okay. Now looking at the new integral, are we going to be able to get the answer in the next step? You think, well, can I take that antiderivative yet? No. Well, if we're not ready to get the final answer in the next step, did we do something wrong? Actually, no. We are doing this correctly. Compare this function here, x squared e to the negative x, with where we started, x to the third e to the negative x. It is getting simpler. But we're not ready for the final answer yet. We're on the right track, but well, what do? We need to do integration by parts on this. There's another integration by parts within the larger integration by parts. Oh my goodness. Here we go. See my arrow there? Do integration by parts again, a second time. So just focusing on this right here, and then we'll know our answer to that integral goes back into the larger picture. Here's what we're going to do. We're going to take u and v in the same way that we began. Okay? So if you need to do integration by parts more than once, when you do it the second time, choose u and dv consistently with the way you did before. So if we said u was x to the third, now we're going to say u is x squared. And if we said dv was e to the negative x dx, well, here it's still e to the negative x dx. When you do it that second time, be consistent. Don't switch it, then you're gonna it's all just gonna be a tangled mess. Okay, so let's talk through this. Well, if u is x squared, then du is 2x dx. And if dv is e to the negative x, hey, it's the same antiderivative, e to the negative e to the negative x, right? And now let's look at that. You probably saw my note there. Pretend you didn't. Okay, so just focusing here. uv minus integral v du. And then I have the simplified version down below. I'll let you guys just kind of read that, copy that. Same style. Just cleaning up, right? The negative comes out in front, negative, negative, okay? Bring the 2 out. And then here we're left with x e to the negative x dx. So all of this goes right there for that integral. Okay, well, will we have the answer in one in one more step? No. Guess what? This new integral, well, it's still getting simpler. Check that out. Like the power of x is dropping by 1 every time. So it went from x to the third to x squared, and now it's just x. But we're not ready yet. What do we need? We need integration by parts a third time. But with this, we're going to get it because those powers of x are fading away. Okay, right here, I've got it on the side. Again, we're being consistent. We're going to pick u to be x and dv to be e to the negative x dx, which you see right here. So if u equals x, then du equals dx. dv is e to the negative x dx. Well, it's that same antiderivative now a third time, negative e to the negative x. And with this, I've run out of space on this page. Maybe I'll try and keep that on the screen. And here's the next line. Okay, so now this is simply what's circled here. uv minus v, and now du is simply dx. All of the powers of x are gone. Okay, we're finally going to get it. Let's simplify here. Negative x e to the negative x plus integral e to the negative x dx. All we got to do is take this antiderivative. Hey, that's the same thing we've been doing over and over again. Okay, so negative x e to the negative x and negative e to the negative x again. It's about the fourth time, plus c. Now, we're not done with the problem, right? This right here goes into that circle, but that's inside something bigger, and that's inside something bigger. So here is the beginnings of the answer to the whole thing. So if you recall, we've got negative x to the third e to the negative x plus 3 times, and that was our first integration by parts, our first new integral. Okay, then 3 times what? So when we continued further, we had negative x squared e to the negative x plus 2, and that was multiplied by another integral. But then we did another integration by parts the third time, and it was negative x e to the negative x e to the negative x minus e to the negative x. That's what we just got a moment ago. The plus c will just be out on the very end of everything. And then if we distribute the 2 and then distribute the 3, we'll get to our answer. I'm just going to show you the final answer right now. Let's see, it'd be negative x to the third e to the negative x minus 3x squared e to the negative x. And then we've got minus 6x e to the negative x minus 6 e to the negative x plus c. There it is. Final answer. So when you do those multiple level integration by parts, don't forget, go back and plug them in. And here we had, 1, 2, 3 levels, right? Okay. Now there is a way when you have what we call this embedded integration by parts, meaning there's more than one. And sometimes there's a faster way. There's this fast method to get to the answer, and the example we saw is one of those. So that's looks like we're going almost 20 minutes on this video, so I'm going to stop this one here, and that's how we'll start the next video.